Welcome to transformations of functions. Today we'll concentrate on the values of a in y equals ax squared. First we're going to graph y equals x squared, and as I told you in class, I want you to concentrate on 3 points. For x equals negative 1, 0, and 1. For 0, 0, that is the vertex of the function. Negative 1 and 1 and 1 and 1 are called the shoulders of the function. Let's look at our first function, y equals 2x squared. I'm hoping you notice the parabola becomes narrower and gets closer to the axis of symmetry, which in this case is the y-axis, compared to the previous parabola, which was y equals x squared. So when a, which is the number in front of x squared, is a number that is bigger than 1, we'll see that the parabola gets narrower and narrower, or we call that a vertical stretch. And the distance between the parabola and the axis of symmetry gets smaller and smaller. And as this new function y equals 5x squared proves it for us right now on the graph. Now, what happens if we're going to graph negative values of a? How will those parabolas look? Well, let's see, first of all, what does y equal negative x squared looks like. If we graph negative x squared, we'll see that the parabola is reflected in the x-axis. Graphically, it looks like an anthill, and it has a maximum point compared to before when it had a minimum point. Well, let's see what happens if I graph negative 2x squared. Well, I have a reflection of the previous function, which was 2x squared. So the distance from the parabola and the axis of symmetry is still becoming smaller and smaller. It's the same as in the case of y equals 2x squared, but it is reflected, or it opens down. Same for y equals 5x squared.